This is the video tutorial for the force calibration on the dual chamber wire myograph system. The calibrations are necessary as the transducers really are the most important part of this system. They record and export the forces generated by your tissues during the experiment, so keeping them in top shape is vitally important. We recommend that the calibrations are done once a month, but doing it more often is only going to help the system. The calibrations are best done under experimental conditions, meaning you have the chamber warmed to 37 degrees Celsius or whatever your experimental temperature is, and you use the same volume in the chamber that you'll be using during the experiment. It's fine to use water for the calibrations. You can also do the calibrations at room temperature, but it's best done under experimental conditions. In order to perform the calibration, you will need a wire on each jaw that's attached to the force transducer, the calibration kit, and make sure that you have the myograph cable plugged in. In order to access the force calibration menu on the touchscreen, you will go into the settings menu and then force calibration. You will then select which transducer you're going to calibrate. In our instance, we'll be doing the near transducer. So you highlight that, select enter. This will tell you that it's a 6-step process and to follow the instructions on the user manual. However, instructions are provided on the touch screen. You can select next step to go to step 2, which asks you to place the calibration bridge and T-balance on the myograph. You will see that the calibration bridge has 2 feet, but these should both be on the chamber itself. You will also see that there is a hole with slots on the side, and this should go over the chamber that you're going to calibrate. So we'll place this over the near transducer. We will then take our T-balance and drop this into the hole on the bridge and use this plate to fit into those grooves. When you drop this in, you should drop it into the rectangle made between the wire that's on the jaw and the jaw itself. Once you have it in that rectangle, you can draw it forward until you engage the wire and then back it off until you see that it's freely moving. The ideal location is just behind the wire without touching it. Once you have the bridge and T-balance in place, you can go to step 3. Step 3 asks you to turn on heat for the calibration. As mentioned before, it's best done at experimental temperatures. However, it takes about 20 minutes for the chamber to warm up to 37 degrees Celsius. You do not want to do the calibration while it's heating, so you should either turn this on earlier, about 20 minutes before you start, or leave it off for the calibration. Go next step, which asks you to make sure that the transducer reading is stable and not drifting in one direction. You will want to wait about 10 or 20 seconds to make sure it's not drifting. If it's going back and forth between 2 numbers, that's okay, but if it's drifting in one direction, it means that you might be touching the wire with the calibration setup. But after it seems relatively stable, you can go to the next step, which is step 5, which asks you to place the 2-gram weight on the T-balance. Now, whichever side you're doing, you will be placing the weight on the side of the force transducer. This will kick the pin forward and engage the wire, which will simulate a vessel constricting. So in our instance, on the near chamber, the force transducer is on the right side, so we will carefully set the 2-gram weight on the right side. You will give this about 10 or 20 seconds to stabilize before going to the final step. The reading should be right around 9.81 plus or minus 0.1 millinewtons. If you're in that range, which we are today, you can go to next step to lock in the calibration before you remove the weight or the calibration bridge. That concludes the force calibration procedure. You can then remove the weight and the calibration bridge. For more information, please refer to the 420A user manual or additional resource videos found on the DMT website.